Hello and welcome to another Reigate Maths video focusing on the second year A-level content for maths. This video is finishing off the binomial expansion topic for the second year, looking at how we can implement partial fractions questions within a binomial expansion question. So this video is just going to look at one example, linking together a partial fractions question into binomial, and then we'll finish there. So we're going to start with this example here. Express 7 plus 5x over 1 plus x times 2 plus x in partial fractions. Now we're not going to go through this. If you need to review partial fractions and have a go at yourself, have a look at one of the previous video on partial fractions. Otherwise, I'm just going to pause the video here and write up my answer. So this is what you should get for your answer, remembering to make sure you identify what you're doing to the examiner, the result of that, and then clearly identifying the process here. Now, for this example, the actual calculation for A, once you let x equal -1, is just, it's there. You don't need to show any working, but you can see for B, we needed a little bit. Now, very important here, we actually answer the question, expressing it in partial fractions, which is this answer. Don't forget that this may well be asked in a different way, in which case you might not have to write this final bit. But given that we're going to use this partial fractions form to do some other bits, it's very important to have it there. So here's the next part of the example. Hence obtain the binomial expansion of the fraction that we just split up to and including the x squared term. So very important is using what we've just done. So I would always start by writing out what we've just done, but in a form that we are more familiar using the binomial expansion for. So we need to turn this into something with a power. So we know it's a fraction. There's no power on the denominator, so it's just to the -1. Now the expansion, as you can see on the right, we write the number first and the x bit second. So I'm just going to swap these around when I write it down here. It's going to make it a little bit easier for us to not make any mistakes. Like that. Now, this one is 1 plus x with a power, which is great. That one we can do straight away. This one is 2 plus x with a power, so it's got to be a little bit more work. But we can use the expansion for this one here because the power is the same. If this was a partial fractions type question where we had a third fraction with a bracket squared, we'd have to very much do them separately. So what I tend to do is I tend to come back to this. If you're worried about it, number the equation just to the side so you can refer back to it. But I tend to take each bit on its own and go from there. So the first bit, 2 times 1 plus x to the -1. So we've got 2 on the outside of a bracket. And then we've got 1 times nx plus n times n minus 1 over 1 times 2 x squared. And remember, the question only wants up to the x squared term this time, so we don't need to go any further than that. Now, you could just expand this straight away and do it all in one step, but don't forget, we're going to use this expansion for this bracket here. So I'm going to make sure I expand this bracket here and sort of tidy everything up inside before I then deal with the 2. So this one's quite a nice expansion because we just get that there. Obviously, now we multiply it all by 2. This means when we come to our second expansion here, we don't need to do quite as much work because we've done it all already. As long as we can be very, very clear what we're using, that we're using vaguely the same thing, we can just use it again. So for our second expansion, we do need to be careful again, because remember, this is not 1, so we need to do some other bits first. So this is going to be 3 over 2 times 1 plus x over 2 to the minus 1. Now remember, because the power is the same as this expansion, we can just use this bracket, but with x over 2 instead. So we get 3 over 2 times 1 minus x over 2 plus x over 2 squared, x squared over 4. And then all we've got to do is multiply that out. Like so. Now it's just a case of putting it all together and answering the question. So therefore, equation 1, which was 7 plus 5x over x plus 1, x plus 2, is going to be equal to these two things added together. 2 minus 2x plus 2x squared plus 3 over 2 minus 3x over 4 plus 3x squared over 8. And feel free to use your calculator to tidy up the common terms. So we've got 2 plus 3 over 2. Typically we leave them as fractions, top heavy fractions at that. So we've got minus 2 minus 3 over 4, so minus 11 over 4x. Don't forget that's the same as 11x over 4. And then we've got 2 plus 3 over 8 plus 19 over 8x squared. And then we're done. That is our expansion. Yes, the fractions aren't particularly nice, but for questions like this, they're not going to be. So just to finish off, we have this part C, find the range of values for which this expansion is valid. So this is a really relevant question because we've done two different expansions added together. So we need to consider the validity of each of them. So let's think about the validity of each expansion. So this was our first one. So this is just 1 plus x, so it's just valid for modulus x is less than 1. Our other expansion is valid for modulus x is less than 2. Because remember, it's the x term less than the not x term. So therefore, expansion in part B valid for, which one do we choose? Well, we look at all of the expansions that we have and we need to pick the smallest interval because that makes sure it covers both. If you think about this, this is x is between minus 2 and 2, this is x is between minus 1 and 1. If we put it on a number line, 2, minus 1, 0, 1, 2, this first validity covers these numbers, the second validity covers these ones. We need to write down the interval where these overlap, which is this one. Very simply, you pick the smallest number. And that's it. That's binomial expansion with partial fractions. Hopefully you can see that there's not a huge amount on top of what we've already done in the past two videos of binomial expansion. It's just a partial fractions question first. These questions are really nice in the exam because they can be worth a decent chunk of marks. However, they can take a long time if your mental numeracy is not up to scratch. So I would strongly advise practicing that if you can. You know, take some very basic questions of fractions, just write down some fractions with numbers in and look at very quickly simplifying them, if possible, without using a calculator. Because as I said before in previous videos, if you can do them without a calculator quickly, it tends to be significantly quicker than typing in your calculator. And that's always going to be the way with arithmetic. If you can do it quickly in your head, it takes a lot less time than typing in your calculator. like things like this, for instance, if you can do it quickly, because you don't need to show any working between this step and this step, if you can do it in your head quickly, it's going to be a lot quicker than typing it in your calculator. Granted, it may be only a matter of seconds, but, you know, in a 2-hour exam, seconds could make the difference. So if you struggle with mental arithmetic, obviously use your calculator. That's what it's there for. But if you can, just push yourself a little bit harder, just to try and really get that extra step of your maths, that'll really help. But thank you for watching.